Well, good afternoon. I'm Chris Scherer, Member Communications Director of the Society of Broadcast Engineers and the co-host of this month's episode of the SBE WEBxtra, the SBE chapter of the web. This is a monthly SBE meeting usually held on the third Monday of the month. The SBE is the Association for Broadcast and Multimedia Technology Professionals with about 5,000 members, mostly in the U.S., but also around the world. The SBE WEBxtra is sponsored by Catrine. Catrine, unique experience, individual solutions, reliable performance. The host of today's SBE WEBxtra is SBE board member Kirk Harnack, who is also the chair of the SBE Social Networking Committee. How you doing, Kirk?
Hey, I'm good. Thank you, Chris. We're about snowed in or sleeted in here in Nashville, Tennessee. How's your weather, Chris? Are you guys experiencing a lot of wintertime weather?
Yes, we are. Kansas City as well. I'm looking at the blanket of snow out my window, continue to increase as the day has gone by. So,
well, I'm looking at a
welcome
blanket
to
of
winter,
sleet.
everybody.
I'm looking at a blanket of sleet, and I'm not going to introduce him just yet. But our guest, he's got us all beat in the snow department. This guy lives in Erie, Pennsylvania, and they get mountains of lake effect snow. It's incredible. Oddly, we're not going to be talking about snow today, though. We're going to be talking about something a lot hotter than snow, and that is fire. That's why I've got fire up here on the monitor, just as a little motif. And today's show, we're going to be talking about fire protection at broadcast facilities. And honestly, in my travels, this is not something that comes up very often, but man, it can be a disaster. But it's a disaster that can be planned for. So Dean Wilson will be our guest. He's been a personal friend of mine for years, and he's a super expert at fire prevention, and especially in broadcast facilities, because he has a broadcasting background. So I'm going to be delighted to introduce Dean in just a few minutes. Chris, you've got a member update for us first, don't you?
Yes, I do. I have your SBE member update for February 15, 2021. Chapters make note, if you are meeting virtually, you should still report those meetings to the national office, just as you would an in-person meeting. These meetings count toward the minimum of 5 meetings held during a calendar year that are necessary to qualify for an annual chapter rebate. If you hold your meetings via Zoom, there is a way for the meeting host to export all the attendee information, which simplifies the chapter secretary's task. Chapter leaders, there's a link to the instructions on the SBE website under Chapter Administration. Go to sbe.org/chapter-admin. The SBE is launching a new series of webinars by SBE, the 2021 IP Networking Series. The first 3 parts are already on the schedule. Part 1, Network Topology and Standards, aired on January 21st. It's now available on demand. Part 2 comes up very soon. It's a focus on Ethernet switching. It airs on February 25th. And Part 3, a focus on everything Layer 3, airs on March 25th. Wayne Pacina leads these webinars. And later this week, on February 18, we present Tower Design Standards. Get to know all the details on ANSI TIA 222 Revision H, including loading, analysis, design, manufacturing, foundations, modification, and maintenance condition assessment requirements. Brian Reese, president of Reese Tower Services, leads the webinar. For information on these and all the webinars by SBE, go to sbe.org/webinars. We just finished the February SBE local chapter certification exam window. The next SBE certification exam window at local chapters is June 4 to 14th. Applications to take an exam in June are due to the SBE National Office by April 16. Also remember, if a local chapter exam is not convenient for you or not possible because of COVID restrictions, private proctoring is available. The new SBE Specialist Certification, ATSC3, is now available as well. More information on SBE certification is online at sbe.org/certification. And that is your SBE member update for February 15th, 2021.
Chris, you could have done this for a living. You're just awesome at that. Thank you. Appreciate that very much.
Thanks.
And I want to encourage people to visit the new SBE website. If you haven't been there, it's spectacular in its layout and design, and it's effective, works well, and there may be even more features coming as we move along. But it's Chris, I know you had a big hand in that, so especially proofreading it. So good job.
Yes, a lot of that went along with the task, right?
Oh my goodness. Well, Chris, today we're going to be speaking with Dean Wilson, Dean K. Wilson. Dean, I've known for some years. He was a Facebook friend. I've got to meet him in person once. And Dean was a former broadcaster. In fact, he got started early in broadcasting. Let's bring on Dean Wilson. Dean, it's great to have you on with us. Good to see you.
Kirk, Chris, it's my privilege to be with you today. Talk to broadcast engineers about fire protection.
Indeed. Give us the thumbnail background of, well, first in fire protection, then we'll find out what your broadcasting connection is. But why do you know something about fire protection, especially in broadcast facilities?
I spent my career in fire protection as a fire protection engineer for a large, highly protected risk insurance company. And we insured some of the largest network and private broadcast networks in the United States. And also we had some involvement with some of the facilities around the world, like the BBC, for example. And part of my task as a member of the national staff was to develop standards and practices that our field engineers used in inspecting broadcast facilities. And I was tasked with that because I started very fortunately at the age of 12 in a local radio station in my hometown in Pennsylvania. And so I had a background in broadcasting that they thought would be helpful in developing the fire protection standards.
I'd like to hear a little bit more about the beginning of in broadcasting. Why don't we do that partway into the show? We'll take a little break from the flames and look at how you got started, because that's an interesting story. Well, I think we should jump right into it. You've got almost an hour worth of material to chat with us about. So, hey, engineers, facility managers, you need to pay attention here. This is going to be good stuff. Dean and I have been over this together once before, and it's all valuable. A lot of very practical information here about keeping your broadcast facility safe. And I think it's amazing and so often true that insurance companies have as big or maybe even a bigger stake in keeping a facility safe and whole than the people that work in the facility, because the insurance company is ostensibly could be paying for it if something bad happens. So there's a lot of incentive there to help the broadcaster, help the facility keep things right. So Dean, maybe we'll start out with some basic questions here. Why should, besides the obvious, why should a broadcast engineer be concerned about fire safety for a facility?
Yeah, Kirk, that's a good question. And whether the broadcast engineer is an employee or a contract engineer, he or she has the best ability to become involved in making certain a broadcast facility remains safe from damage a fire could cause. He or she is likely to be the most logical thinker on the management team because of his or her engineering background, and the broadcast engineer knows the facility better than anyone else. He or she will likely also be the one who has to put the facility back together should it become damaged in a fire. So the broadcast engineer has the ability to learn the technical knowledge necessary to formulate proper protection strategies for a broadcast facility.
Dean, I got to tell you, the facilities that I take care of, they tend to be smaller, small town facilities. And unless there's something that's just obvious and egregious, I don't think about fire protection much at all. And I really should. So if I'm thinking about a facility, and I've worked in some larger facilities, and I just kind of always assumed that they were already thinking about this, where does a broadcast engineer begin in thinking about fire safety and protection?
That's really what I want to talk about today, Kirk. Where should the broadcast engineer begin? And what I'm going to suggest to the broadcast engineers listening to this presentation is they perform what we call a fire hazard identification and analysis for each broadcast facility where he or she works. This fire hazard identification and analysis should be structured to consider 5 general goals for fire safety at a facility. And those goals are, first of all, life safety, the safety of the personnel who actually work at the facility. The second is property protection, the preservation of the actual physical property, the equipment that's contained therein from fire. And the third one is one that people don't think about a lot, but it's very important, and that is the continuity of the mission. That is to say, the mission continuity, the ability of the radio station to continue what it needs to do, either to make a profit for the owners, or in the case of a nonprofit, to fulfill the objective for which the nonprofit radio station or television station was created. The fourth goal that we look at in fire safety is what we call heritage preservation. And that's kind of a strange term, but it refers to anything that's related to the operation of the facility that must be retained for a long period of time. It could be historical information. It could also be record keeping, all kinds of business information. In the case of an automated facility, it could be the hard drives or cloud storage of the various content that the radio or television station is using. So heritage preservation is something that can definitely be affected by a fire at the facility. And then the last category is more of a community interest, and that's environmental protection. There are occasions where the fire in a broadcast facility will have a negative impact on the environment. So with those four main goals and the fifth one, environment, in mind, the broadcast engineer should perform this fire hazard identification and analysis by examining all the parts of the broadcast facility using something we call the DIM2 process. DIM2 stands for design, installation, maintenance, testing, and use. Say that another way, as the broadcast engineer encounters each possible fire hazard at a broadcast facility, the engineer should ask himself or herself the following questions. And this goes back to what you said at the beginning, Kirk, where the broadcast engineer is not normally consciously aware of the fire hazards at a facility. Oh, there may be some common information that he or she's picked up, but what we're going to try to do today is focus that basic knowledge specifically to the kinds of hazards that we encounter at a broadcast facility. Here are those questions. Is the design in which this particular hazard exists suitable, or does it need modification? So that's the D of the DIM2 process. Number two is the installation of the equipment relating to the hazard proper and safe, or should the equipment be reinstalled in a safer manner? Third, are the maintenance operations and testing related to this hazard proper and safe, or should the maintenance and testing procedures be modified to improve safety? And fourth, is the use of the equipment related to the particular hazard safe, or should the procedures for the use be modified to make them safer? So keeping that background information in mind, let me illustrate how a broadcast engineer would employ the DIM2 process by looking at some of the more prevalent hazards at a broadcast facility.
Good. I was going to ask you for some examples, indeed.
Yeah, and that's what we'll do. We'll talk about some very specific examples. Okay. It'll be no surprise to a broadcast engineer that electrical is probably the most common and most serious hazard at a broadcast facility. The electrical hazard directly affects life safety, property protection, mission continuity, and heritage preservation, and in some cases, it might possibly affect environmental protection. So in conducting a fire hazard identification and analysis for the electrical installation at the broadcast facility using that DIM2 process, the broadcast engineer should explore the following. First, does the design and installation of the electrical wiring and equipment at this broadcast facility meet the requirements of National Fire Protection Association Standard 70? That's the National Electrical Code. Most engineers do not realize that Nfpa 70 covers the proper design, installation, maintenance, and testing of all the electrical equipment and wiring in a facility. Of course, it covers the distribution of operating power throughout the facility, but it also covers the wiring, equipment associated with signal transmission, including optical fiber cables, signal cables, remote control, wiring for audio and video distribution, and so forth. Every aspect of the design, installation, maintenance, testing, and use of the electrical system at a broadcast facility must meet specific requirements in Nfpa 70. And this means that the broadcast engineer and his or her technicians must have at least a rudimentary knowledge of what the National Electrical Code, Nfpa 70, requires and how to implement those requirements. It might be of interest to those watching that back in the late 1990s and early 2000s, I was the chairman of what was then called Code Making Panel 16 of the National Electrical Code. We were the committee that when the National Electrical Code technical committees met to revise the code, which they do every 3 years, we were the fellows off in the corner that everybody laughed at. The reason they laughed at us is we had such things under our jurisdictions as pipe organs, the wiring for a radio and television station, optical fiber cables, the wiring for fire alarm and burglar alarm systems, the wiring for the distribution of cable TV systems within a building, and all of those kinds of what the electrical inspector calls the back part of the electrical code, because the chapters appear in the 600, 700, and 800 series, which is toward the back end of the code. And even today, I find as I go around and try to help people that the electrical inspectors in most jurisdictions know very little about that back end of the code. They're very good about the power part of the code, but when it gets into the technical requirements for that, all those other wiring systems, they're not very knowledgeable. And actually, for the broadcast engineer, apart from the very basics of power distribution within the building, most of the focus of the broadcast engineer is going to be on those latter chapters in the code. Now, since the time that I chaired that code making panel, Code Making Panel 16 has been broken up, and some other code making panels have taken on the responsibility for some of those back-end chapters. But nevertheless, it becomes important to understand that wiring isn't to be installed willy-nilly, and the connection of equipment isn't to be done willy-nilly. It has to be done in accordance with the code. Doing that is the first step of making certain that the wiring or equipment does not contribute to a fire. The second question in regard to electrical, as the engineer is performing this hazard identification and analysis, is does the maintenance and testing procedures for the electrical wiring and electrical equipment at a broadcast facility meet the requirements for safety, or should those maintenance and testing procedures be modified to assure a greater level of safety? Let me give you an example of that. When I was first in radio as a teenager, the chief engineer of the small radio station where I was working would ask me to go with him after the station signed off at midnight, that's when he would do the proof of performance on the AM broadcast transmitter. And he would make adjustment, open the transmitter up, defeat the interlock on the front of the panel so that he could power the transmitter up with the door open, and then make adjustments inside so that the proof of performance would be acceptable for that AM station. He always wanted somebody else there with him because he was concerned that if he touched something he shouldn't, or became ill and fell into the inside of the transmitter while it was on, he could be very severely injured. That kind of thinking, that thinking about safety, thinking about the ramifications of safety, is the kind of thing we're talking about here, focusing our attention on fire. So there is a National Fire Protection Association standard. It happens to be Nfpa 70E. E is in Edward. And that's the standard for electrical safety in the workplace. And it contains a variety of helpful information that can guide a broadcast engineer in examining, developing, or revising maintenance and testing procedures for the electrical wiring and electrical equipment at a broadcast facility. Another question in regard to this is, do the procedures for the use of the electrical wiring and electrical equipment at the broadcast facility meet requirements for safety, or should those use procedures be modified to assure a greater level of safety? some of that has to do with more than just fire protection. If you think about the operational integrity of the radio station, keeping the radio station on the air, making certain that something that someone who is not familiar with the totality of the engineering might do that could knock the station off the air. And I'll bet among the broadcast engineers watching this WEBxtra, there would be a number of individuals who could relate war stories of how some jock or some other person in the broadcast facility has inadvertently knocked the station off the air. All of those kinds of things weigh into an analysis of the hazards, and they might involve fire protection, or they might simply involve that mission continuity that we talked about earlier on.
You know,
So
I can think of Dean, I can think of a number of cases where something was done. Typically, something was wired at a broadcast facility because it seemed like a good idea at the time. You know, it seemed like a convenience, and so often back a couple decades ago, you'd open up an audio console and you'd start doing a little bit of work, and it was supposed to be all low voltage in there, and your wrist would come across the back end of a lever switch, and you'd get a shock. And oh my goodness, they wired the 110 volt motor for the turntable to some extra contacts on the lever switch. And obviously this is pretty dangerous. And we found out about that a few times. And other people wiring 120 volts on what should be audio cable, just because, well, I've already got a run of cable going over there, and it's just going to run this little relay. It's very low current. It doesn't really need to be, you know, some Romex wiring or protected. Well, so I've got a number of diagonal cutters that, you know, have notches in them from cutting such wires. Is that the kind of thing? Is that the kind of use thing you're talking about?
That's exactly what I'm talking about. Because unfortunately, some of these radio stations, although most automation today has taken care of a lot of this, but some of the radio stations, particularly years ago when I was in radio, there's somebody there all night long who's not an engineer. And the temptation to play overcomes them, particularly if they've brought some liquid refreshment from home that maybe the management would not want them to have. And I can just imagine some of the circumstances that people have gotten themselves into when they have time to play with things that they shouldn't be touching, that should be left up to the broadcast engineer and the technicians. So what I've tried to do in just a few minutes is give a look at the electrical. And the thought process, again, is to go through this design, installation, maintenance, testing, and use, and to examine the procedures associated with that to make sure that those hazards are disclosed. What we're trying to do is look at the broadcast facility and think through the possibility that something that we've walked by day after day, month after month, maybe even year after year, could actually represent a serious hazard, and it's just never come into our consciousness. So by thinking logically, and one of the great wonderful things about broadcast engineers is their whole world is the world of logical thinking. And so they are the ones most equipped in a broadcast facility to be the ones to help preserve the facility by understanding and identifying the hazards that are present. Let me give you another example. Extraneous combustibles. The improper control over the accumulation of extraneous combustibles can represent a significant hazard in the broadcast facility. When I say the word extraneous combustibles, what I'm talking about includes, but probably is not limited to, things like trash, paper products like paper for the printers or paper for the fax machine. In the old days, it would have been paper for the teletype machine from either Associated Press or UPI. Building materials that might be stored on site, lumber, trim, sheeting, stuff that's left over from a remodeling project or that somebody is holding on to in the hopes that there will be some remodeling. Paints and finishes, including thinners, and even unused wiring. A lot of people forget the fact that most wiring today is insulated by a combustible plastic material. And if you get enough quantity of wiring, the plastics in the insulation can represent a very serious hazard. Most people don't realize that plastic materials, because they are petroleum-based, burn with the ferocity of gasoline. They give the same kind of heat release rate that burning a can of gasoline might cause. And so if you accumulate, I've been in some engineering shops where they've got stacked over in the corner a 4-foot high pile of cables. Now, they may be old cables that they pulled out and just have never done anything with, or they could be new cables that they've got standing by for some remodeling project that they never seem to get around to doing. But nevertheless, these are what we call extraneous combustibles. So wherever the broadcast engineer discovers such material, again, the application of the design, installation, maintenance, testing, and use, the DIM2 process, will often disclose that he or she needs to formulate a written plan for getting those extraneous combustibles removed from the broadcast facility. For example, trash should be collected in metal waste baskets, not plastic, and they should be emptied at least daily or more often into outdoor storage containers, also of metal construction. The bulk storage of all kinds of paper products, the paper in the Xerox machine, the paper in the printers that they might have on the facility, or it could even be paper materials or plastic cups, the kinds of things they might have in the break room. All of this kind, the bulk storage of these kinds of products should be kept in a central location and stored inside metal cabinets with closable doors. Unused building materials should be kept outside of the broadcast facility, or at least in a cut-off storage room. When we use the word cut off, we're talking about at least a 2-hour fire resistance rating. Now, we can achieve a 2-hour fire resistance rating by using overlapping layers, 2 overlapping layers of gypboard, where the joints do not appear in the same place on the sheets. In other words, the joints of the gyprock overlaps each other. And so you can create a 2-hour fire resistance rating pretty easily. And there are a number of Underwriters Laboratories acceptable ways of doing that using just ordinary gypsum board. Unused wiring should be stored in a metal cabinet with a closable door. A large amount of unused wire cables, such as might be used in a major remodeling or for the replacement of, say, a transmission line, should be stored outdoors, preferably 50 feet away from the building. So if somehow it is ignited and catches on fire, it won't provide a serious exposure threat to the building where the broadcast equipment is located.
Dean,
Look, if I may,
before the show,
yep, sure.
Before the show started, I made a little joke, but it's not really a joke. I've been in radio stations that had a prize closet, and stuffed in the prize closet were, tons of bumper stickers, which were paper and vinyl, right? And trinkets and tchotchkes and maybe some remote equipment, and sometimes a whole bunch of shelves full of liquor for the sales meetings that in the evening. I would take it that this is not the best practice.
Yeah, it would be a better idea to store all of that in a metal storage cabinet. So the whole idea of the metal cabinet is, if there is a fire in the room, the metal cabinet will provide a small amount of protection against the conduction of heat, the transmission of heat. But more so if something inside that cabinet. We had one fire in a radio station that happened in exactly what you're describing. And what it was, they had a bunch of toys that ran on batteries, and they ran on 9-volt batteries. And the 9-volt batteries, over time, because they'd been in that closet for quite a while, the 9-volt battery degraded to the point where it started to short out. And it was just enough joules of energy to ignite this very fluffy cotton cloth that this toy was wrapped in. I think it was a teddy bear, but I'm not sure about that. And that caught that whole closet of stuff on fire. And unfortunately, that closet was right next to the main equipment room for the facility. And there was they had not put the equipment room in a cutoff, at least a 2-hour fire rated enclosure. And so the fire just went through the wall of that closet into the equipment room. And it wasn't so much the damage by fire, although there was some damage by fire, but the smoke. People don't understand how acidic smoke is. And the smoke did all kinds of damage to the contacts on the electrical equipment in that equipment. Everything from the compressors and mic processors and all of the equipment associated with the AIOP that they had for the station were subjected to that smoke. Now, there are ways that can be salvaged, which we're going to talk about in a little bit, but in that case, they didn't know about that, and the insurance company that insured them didn't know about it. And so as a result, there was a very significant loss from a fire that should have really never happened.
Well,
let me talk. Okay, go ahead.
Yeah, go ahead. Well, I think you're going to get to the hot work. Is that what's next?
Yep. Mm-hmm.
Yeah, want to talk about so many of us engineers are amateur welders and amateur brazers and amateur silver solderers, right? Especially at AM facilities or a new FM facility, or even when you've got a studio facility that's co-located with a transmitter and you need to get the grounding really right. We are working with flames and MAP gas or acetylene, oxyacetylene that we may not work with very often. So what are some dangers there, or what are some ways to mitigate those dangers?
Yeah, this is another example of hazards that we routinely find at broadcast facilities. We call it soldering or other hot work, the use of heat-producing maintenance equipment that can be brought into a broadcast facility is an additional source of possible ignition that may cause a fire within the facility. And the application of the design, installation, maintenance, testing, and use, the DIM2 process, to develop a fire hazard identification and analysis for the facility will quickly highlight the possible hazards that hot work may produce. Some of the things that the broadcast engineer should consider include only rarely will actual welding or cutting, the use of arc welding, acetylene torches, silver soldering will be necessary at a broadcast facility. It is from time to time, but it's not something that happens every day or even every week, every month. It's a rarity. But whenever welding or cutting is conducted, a strict set of procedures should be followed to ensure that such use does not start a fire. And those procedures are documented in a number of places. If someone searches for hot work protection on the internet, they'll find a variety of sources. The NFPA, National Fire Protection Association, has a standard on the protection of hot work. And all of those kinds of helpful procedures are present. And rather than take the time to go into them, they can search for those on the internet and find them. In contrast to that kind of hot work, broadcast engineers and technicians will frequently need to use soldering. Maybe a little bit less today than in the past, now that we're using various kinds of interconnection for AIOP at most broadcast facilities. But again, the application of the DIM2 process will determine whether or not such soldering is safe and follows the appropriate guidelines. For example, all hot work should be done in an area and kept clear of extraneous combustibles. Now, obviously, if you're soldering inside a rack or inside an enclosure of broadcast equipment, you're going to have to take some kind of precaution. And there are flame-proof tarpaulins that are made of various thicknesses so that you can get one that's pretty much like a blanket as far as being able to mold around the stuff you're trying to protect. And if you're going to do any lengthy soldering operation, you ought to protect the other equipment in the immediate area so that you don't inadvertently set something on fire. We've even had fires started. We had one fire started at a broadcast facility where the ringing of a telephone caused an engineer to drop the soldering iron. It happened to fall against a piece of wire in a rack, a cable actually in a rack, and ignited that cable. And before they could get the fire extinguisher, it flamed out of control. So there's these kinds of things can be anticipated. And that's one of the reasons we always, when we're doing any kind of hot work, we keep appropriate fire extinguishers nearby. And I'm going to talk about my recommendation for the kind of fire extinguisher we should use in a little bit. Soldering irons should be placed in UL listed holders, never just randomly laid on work surfaces. There are plenty of UL listed holders for soldering irons that are portable. You can bring them along when you're done soldering. You can stick the soldering iron into the holder, and it's got a weighted base so it won't tip over easily and so forth. And of course, the work area should be kept clear and clean before soldering begins, at least as much as possible. So once again, as an illustration with hot work, through the DIM2 process, the broadcast engineer can assess the use of hot work as a possible increase in the fire hazard at a facility. I'm about midway through my examples, Kirk. If you want to take a break, or if I can forge on, it's up to you.
Well, I want to see if Chris Scherer had any questions at this point. You and I have been over a lot of this before, and you're hitting all the points that I want to know about very, very well. Chris, are we missing anything from your engineering experience at this point?
Well, just I had one question that was more on the practical side of things, I think, and you've touched on it a little bit here and there. I think of at least more on the transmitter side of things, where there are chemicals being stored, whether it's cleaners or lubricants or whatever. Some of that stuff you just have to keep on hand. What are some practical tips as far as how do you store it? How do you make sure that it's not causing a problem? What can you do to mitigate a potential disaster if something inadvertently happens anyway?
Chris, that's an excellent question, and that actually is a good transition to my next example, which is the storage and use. Indeed, and you did. That's the storage and use of cleaning supplies, flammable and combustible liquids. And as with the previous examples, the application of the design, installation, maintenance, testing, and use, the DIM2 process at a broadcast facility, will quickly disclose the impact of substances used for cleaning the facility or even operating parts of the facility may have on the fire hazard identification and analysis. For example, cleaning supplies, especially flammable and combustible liquids, and unused cleaning rags should be kept in a metal cabinet with closed doors, closable doors. The use of cleaning rags should be, once the rags are used and have cleaning solution on them, they should be kept in a covered metal container and preferably removed from the interior of the premises to an exterior storage container on a daily basis. Flammable and combustible liquids within the broadcast facility should always be stored in UL listed metal safety cans equipped with flame arresters in a size not exceeding 2.6 gallons. And for a business facility, which in the building code, the various types of facilities are given rules and regulations, and a broadcast facility falls under the category of business. And so there's a limit to the amount of flammable or combustible liquid that can be contained within a single container. And that's 2.6 gallons. And the reason for the 2.6 is because they switched over to metric measure a number of years ago, and 2.6 gallons is the equivalent of some even number of the metric system.
Probably 10 liters, I think. Probably about 10 liters. Yeah.
Okay, that makes sense. I try to avoid the metric system as much as possible because I'm an old man, and we all know that even a system as logical as something that is based on 10, I'm going to stick with pints and gallons and all of those kinds of things, inches and feet. And in any case, so we store the flammable and combustible liquids in a UL listed metal safety can equipped with a flame arrestor. A flame arrestor is a screen that fits down inside the opening so that a flame can't enter into the can. That screen that fits down inside acts like a heat dissipator. And then once I've got my liquids in no more than 2.6 gallon in safety cans, I keep those in a UL listed flammable liquid storage cabinet. And that flammable liquid storage cabinet is basically a heavy duty metal cabinet that can be closed. And it does provide a significant, because it's made of heavier metal, a significant dissipator of heat. And also, in some cases, it's provided with a vent to the outdoors, so that if in a fire, the contents of the cabinet becomes heated, the safety cans are going to slightly open and release the vapors so that they don't blow the can open. And that vapor can then be exhausted out of that flammable liquid storage cabinet by either natural ventilation or by a small outdoor fan. And so that's the best way to handle that. And broadcast facilities, business occupancies, are allowed to have no more than 10 gallons of flammable or combustible liquids stored inside the building, inside the business occupancy. Fuel for standby generators should be stored outdoors. In choosing a generator, either natural gas, liquid petroleum gas, propane if you will, or diesel fuel generators are preferred over gasoline fuel generators. And the reason for that is gasoline has the temperature at which gasoline produces vapors that can be ignited is minus 45 degrees Fahrenheit. When we look at diesel fuels, the temperature to ignite or to heat diesel fuel that are used in generators with all of the additives that are in the diesel fuel, it raises the temperature at which it begins to produce ignitable vapors to 126 degrees Fahrenheit. So you can see minus 45 to 126, diesel fuel is much safer than gasoline. So we try to encourage broadcast facilities either to choose natural or LP gas or diesel fuel generators as opposed to gasoline fuel generators. But in any case, the generators at a broadcast facility should be designed, installed, maintained, tested, and used in accordance with yet another National Fire Protection Association standard. It's NFPA 110, which is the standard for emergency and standby power systems. Whenever liquid fuel must be transported, it should be contained in a metal UL-listed safety can that has been secured, preferably in the back of a vehicle that's open to the air. In other words, the back of a pickup truck, for example. And when we say secured, we mean tied down so it can't tip over. And we never keep any kind of fuel, even in a safety can, inside a vehicle or in the trunk of a vehicle. The reason for that is in the summertime, it gets pretty hot inside some vehicles, and particularly in the trunk. And if it gets hot enough that vapors begin to be produced by the fuel in the safety can will open, and pretty soon you've flooded your trunk, for example, with ignitable gasoline fumes. So that's why we want all transportation to be done in the exterior. When liquid fuel is dispensed from a safety can to the fuel tank of a generator, a metal bonding strap should connect between the metal safety can and the metal fuel tank. And that prevents the buildup of static electricity. Because believe it or not, there are circumstances where the pouring of liquid from a safety can into the fuel tank of a generator can generate sufficient electrical energy, joules of energy, to ignite the vapors and cause a fire, or worse, an explosion. And we use that same practice with any flammable or combustible liquid that we're dispensing from a safety can to another container. That metal bonding strap should connect between the metal safety can and the container into which we're pouring the liquid to prevent that buildup of static electricity. Again, as with the previous examples, we're using this design, installation, maintenance, and testing and use process to disclose any potential increase in the fire hazards at a broadcast facility. In this case, that the storage of cleaning supplies, flammable, and combustible liquids can create. So, Chris, did I answer your question?
That and some.
Okay.
Quite
All right,
thoroughly,
good.
I'll add.
All right, well, then I'm on the right track.
Hey, Dean,
Kirk, you want me to?
well, you've got a topic coming up here that used to be everywhere. And now I'm not going to disclose what it is. I'm going to let you say what it is. But now it's pretty rare, but it still exists. And in fact, sometimes it's a little bit, shall we say, underground or behind the building, and so I guess what I'm saying is it might be a little bit slipperier, harder to think about or detect these days, or think, oh, I should warn about this, or I should make sure the area where this activity is going on there's nothing flammable here. So why don't you introduce us to what we all should know, but I think we forget about sometimes.
Okay, Kirk, I will. This is another area that over the years has proved to be the cause of significant fires in broadcast facilities. And it's a subject that's very controversial to some individuals. I would want to say something psychologically about it, except that that's not fair, because every one of us is an individual. We have the right to live our lives the way we want to. The subject is smoking. And so again, the DIM2 process, the application of design, installation, maintenance, testing, and use, can disclose possible sources of ignition that might negatively impact the fire hazard identification and analysis for a broadcast facility. For example, smoking introduces a possible ignition source and should be strictly regulated within a broadcast facility. The presence of smoke in the air also poses a significant life-reducing effect on the broadcast electronic equipment. When I started in broadcasting, I was 12 years old, and literally every single person at the radio station except me smoked. And I mean, I started to have my own shift when I was about 14. And when I came on, I had a 4:30 in the afternoon till midnight shift, 5 nights a week. And when I came into the broadcast facility, as a non-smoker, I could barely see the disc jockey behind the control board because of the cloud of cigarette smoke. And if anybody that's been in a broadcast facility from yesteryear, that's very often the case. Now, nobody, at least that I was aware of, ever gave a thought to the fact of the damage that smoke was doing to the electronic equipment. And the truth is, smoke is acidic. And cigarette smoke, especially nicotine-charged cigarette smoke, is particularly acidic. And I've got a broadcast control facility for radio or television that in some cases, I've been in some network control centers in New York that I know from the insurance value, we had 10 or 15 or $20 million worth of electronic equipment in the space of that control room. And the whole concept of subjecting that value equipment to acidic smoke, I'm flabbergasted when I think about it. Of course, over the years, the smoking has become out of favor in a lot of places, and there are some specific things that can be done. So the way we do it is we strictly enforce the prohibition of smoking, except in designated smoking areas. And those designated smoking areas have to have, number one, good ventilation to the exterior of the building. And obviously, to do that, there has to be good makeup air. We have to have metal ashtrays that are substantial and heavy, or ceramic ashtrays that are substantial and heavy. And we have to have provision for emptying those ashtrays into covered metal receptacles, and the ashes should be removed from the premises, preferably on a daily basis. And those are just good practices. And many broadcast facilities are making it a fireable offense if someone chooses to sneak a cigarette in the bathroom or in a back room somewhere. And there have been a number of fires that have been traced back to carelessly discarded smoking materials. And from an operational standpoint, this falls into the same kind of category as where we allow people to drink their beverages or eat their lunch. Again, when I was in broadcasting a lifetime ago, everybody ate their lunch right at the console and drank their coffee, or in fact, I can't tell you the number of times we had to try to clean up the gates board that we had because somebody had spilled coffee on it. And of course, in those days, we're talking about a much steeper slope than the consoles have today. And it was a rotary pot instead of the slider. And there was less potential for damaging the inside of the console than there is today. But forbidding that, food and drink from the electronic rooms is something that a lot of broadcast facilities have done, and for good reason.
No more smoking in the boys' room, not even at rock stations.
Yeah, and especially at rock stations. Yeah, especially the kind of smoke sometimes that people would smoke is also a factor. It wasn't back when I was in broadcasting, or at least regularly in broadcasting, but I know I've heard stories, let's put it that way, of some unique smoking materials in some broadcast facilities.
A fire does break out, and I think you've got fire suppression on your mind at this point after the fire does break out.
Yeah, if a fire should occur at a broadcast facility, the objective is to contain the fire to the immediate area of origin, or the place where the fire was ignited, and to prevent its spread throughout the facility. We use a combination of fixed fire extinguishing systems and the availability of hand-portable fire extinguishers to provide the best protection. As a broadcast engineer looks at this aspect, fire suppression and control, we can again rely on this DIM2 process, design, installation, maintenance, testing, and use, to disclose the potential hazards and to determine whether the procedures that we've enforced are going to take care of it in the most cost-effective way. The most reasonable protection, and this is going to cause some broadcast engineers to shrug their shoulders a little bit, but the most reasonable and cost-effective fire suppression system in a broadcast facility is a wet pipe automatic sprinkler system. Now, let me hasten to say, as most people probably realize, the way that Hollywood predicts or portrays the operation of a sprinkler system is not the way a sprinkler system really works. When there is a fire, all of the heads do not operate in a facility. Each individual sprinkler head in a facility, in the most common wet pipe automatic sprinkler system, has its own fusible element. And somebody said to me one time, well, how much fire does it actually take? And we used the example, the amount of fire that would contain a 6-foot tall person. In other words, we're not talking about some little fire in a wastebasket. We're talking about a significant quantity of fire. The reason for the wet pipe sprinkler system is that if the fire gets started and it grows to the place where it becomes a threat to involve more of the facility, the operation of usually 1, 2, or in some cases 3 sprinkler heads will contain that fire to the area of origin. There have been a number of studies done over the years about how many sprinkler heads it takes. The U.S. government Department of Energy did a facility at nuclear facilities a few years ago, and they keep very good fire records. Since the fire at Rocky Flats a number of years ago, now more than 40 years ago, and they've kept really good records, and the average number of sprinkler heads that operate in a credible fire is 2. So generally speaking, in a business type occupancy, in most cases, the number of sprinkler heads that are going to operate to control the fire and hold it to the area of origin is 1. So the most reasonable, and I say again, cost effective, is the wet pipe automatic sprinkler facility. Another thing that's important to understand is fires that have occurred in other kinds, in broadcast facilities, but in other kinds of facilities with high value electronic equipment, is that most of the electronic equipment can be salvaged even though it becomes wet from the discharge of a sprinkler head. Now, if the fire department has to come in and use hose streams, that's a whole nother situation, because the amount of water discharged by an automatic sprinkler head is very, very small compared to the amount of water discharged by even a booster line off an engine or an 1.5-inch hose line. So it's far better to have the fire held to the area of origin by a single sprinkler head. We have techniques that we can use to salvage electronic equipment. We wash the equipment with deionized water and use low velocity warm air drying to dry the equipment out. And the design of most electronic equipment today, we find that even components that you would expect to be damaged by the discharge of water, no problem whatsoever. And the equipment goes right back into operation. And by the way, this is not something new. We learned this for the first time back in 1964 with a fire in a computer manufacturing facility in West Palm Beach, Florida. When back in the time when RCA was building computers, they had a fire in a computer test room. Sprinklers operated, controlled the fire. They took those 7 computers. These are now, we're not talking about laptop or desktop computers. We're talking about mainframe computers. They took those and put them out at various RCA facilities, and they kept maintenance records on them after they had been cleaned with deionized water and warm air dried. They had no worse of a failure rate than any of their other normal equipment that had not been in that fire. So also, it's interesting to note that the accidental operation of a sprinkler head has been statistically determined to be 1 in 16 million. So the chance of a sprinkler head just going off on its own is so low that it's not a good reason for omitting automatic sprinklers. Now, if you have very high value electronic equipment in an equipment room, like you might have at a network television broadcast facility, they might use what we call a clean agent system as the primary fire suppression system. And that would typically be actuated by cross-zoned smoke detectors. In other words, it would take 2 smoke detectors either horizontally or vertically in the space to trip the actuation of the clean agent system. But even when we use clean agent systems, we always try to back them up with wet pipe automatic sprinkler systems. If someone has a very unusual fear of water, there are special types of sprinkler systems that are double interlocked. It takes it takes the operation of a heater smoke detector plus the operation of the sprinkler head before water flows. Frankly, we typically use those in something like a freezer where we're protecting in a large cold storage, freezer storage warehouse. But we have had some broadcast facilities pay a rather exorbitant amount of money to put in that kind of system just because of their fear of water. But I will also tell you that those systems do not operate as rapidly in a fire as the ordinary wet pipe sprinkler system. Let me talk for just a moment about fire extinguishers, because every broadcast facility should have the appropriate kind of hand-portable fire extinguishers throughout the facility in accordance with National Fire Protection Association Standard 10, which is the standard for portable fire extinguishers. And the choice of extinguisher should be based on the category or classification of the fuel that we anticipate. And we have 4 categories, classes A, B, C, and D. Class A is wood, paper, or any combustible material that when it burns leaves an ash. Class B is flammable and combustible liquids and greases. Class C is any fire involving energized electrical equipment. However, once the power is turned off, the classification of the fire reverts back to the classification of whatever fuel is burning. In most cases, that'll be Class A. A Class D fire you will probably never see in a broadcast facility, except possibly in some standby batteries, because Class D is fires in combustible metals, such as magnesium, titanium, zirconium, lithium, potassium, and so forth. These are metals that when water is applied, they liberate the oxygen from the water and burn more fiercely. So we have special kinds of extinguishing for them. Here's my recommendation. I strongly recommend that broadcast facilities choose 2.5-gallon water extinguishers rated 2A for their ordinary extinguisher throughout the facility. And for any place where there is a concentration of electronic equipment, especially high-value electronic equipment, I recommend 10-pound carbon dioxide extinguishers rated 5BC. The reason I'm choosing carbon dioxide is that it extinguishes fire by displacing the oxygen. And when the fire is extinguished, it leaves no residue. The very popular extinguisher that people buy is the dry chemical powder. In fact, you can buy a dry chemical extinguisher that's rated for A, B, and C fires. However, the dry chemical powder that's discharged by a dry chemical extinguisher is very insulating, and it makes an awful mess. When I was a small boy, there was a Western Union switching station in my town that had a fire. The fire department arrived on the scene, and they had just been issued for the fire trucks something brand new on the market called a dry powder extinguisher. You have to imagine a 3-story high space filled with a rack of wiring over which the Western Union telegraph signals were transmitted. The fire was in that rack. The wiring in that rack was copper wire covered by a paper insulation, and a cable was on fire. They used that dry chemical extinguisher. It put the fire out very promptly, but it took them 6 months to clean the contacts in the open relays of that switching center. And the actual after-fire cost was astronomical in those days, and it was about 1956 or 1957 or so when that fire occurred. CO2 leaves no residue, and it's an excellent extinguishing product. And I think that based upon the expensive electronic equipment at a broadcast facility, that's what I would put wherever there is a concentration of electronic equipment. Certainly in the control room and studio, certainly in the rack room, certainly in a transmitter building. I would have both the 2.5 gallon water for a fire that might be in trash or in some kind of combustibles, but I would have the CO2 extinguisher for fire within energized electrical equipment.
Dean, we're going to be short on time here. Take your conclusion points and put them in the show notes, if you don't mind, and people can read those for themselves and answer their own questions. Could you cover this last item in a couple of minutes about fire protection surveillance? What does that mean?
Okay. Yeah. Let me just quickly say one thing about the fire department.
Yeah.
It's critically important that the first due engine company and first due truck company or ladder company that will respond to a broadcast facility become familiar with the layout and hazards of the broadcast facility. So management should invite the members of the various shifts of those companies to visit the facility. And the broadcast engineer should be the one leading the tour to help the firefighters become familiar with the facility. This will help minimize damage from the responding fire companies if they have to respond to the broadcast facility. When we talk about... Go ahead. I'm sorry.
Show them where the rack room is and where please keep the hoses out of here unless it's just, Katie bar the door.
And pretty much if you've done a good job in designing the fire protection systems for your facility, there will be no reason for them to bring hose lines into the building.
Good.
Good. The last item you want me to talk about, which is fine, is the fire protection surveillance. It's important that we get a prompt notice whenever a fire exists within a broadcast facility. So every broadcast facility should be equipped with a fire alarm system using UL listed equipment and connected to some remote monitoring location, either a UL listed central station or a UL listed remote station. The fire alarm system should be designed, installed, maintained, and tested in accordance with Nfpa 72. That's the National Fire Alarm Code. Generally, the facility should be equipped with system smoke detectors connected to the fire alarm system. Spaces where personnel do not normally occupy should be protected by UL-listed heat detectors connected to the fire alarm system. If the facility has fixed fire extinguishing systems, sprinkler systems, or clean agent systems, they should be monitored by the fire alarm system. For example, if it's a wet pipe sprinkler system, the fire alarm system can monitor whether the sprinkler control valve is open or not. And if the sprinkler system operates, the fire alarm system can monitor that the sprinkler system has operated. In the case of the control valve, we call that a supervisory signal. And that also can be transmitted to the remote facility so that you can take steps to promptly restore it to service. Okay, let me just wrap it up by saying we're asking the broadcast engineer to make this evaluation, identification, and evaluation using the DIM2 process. We're basically saying what sources of fuel exist that might become involved in a fire, what sources of ignition exist that might start a fire, what can we do to limit the fuel and control those ignition sources, what protective systems can we employ to keep the fire within the immediate area of origin, what management procedures and practices can we devise to accomplish our fire safety goals and enabling objectives, and what planning can we do to promptly restore operations if a fire occurs.
Dean, that is quite a coverage of this topic. We've done it in just about an hour, just a hair over an hour. Dean, I'd like to make your notes available to people in a written form. You and I can talk about what that would be what would be the best way to do that after the show. I'll get back in touch with you and see if we can include that in the show notes or a separate document or something like that, so people can review what you've talked about here on paper or on screen. Would that be okay?
Absolutely.
Good deal. Good deal. Chris Scherer, I don't know if we have any time for any more questions. We're just about out of time, but I feel a lot better informed now than I did before and learned a few things. How about you?
Absolutely. As I had said in the some of the promos before we went to air today, I think this is a topic that a lot of us don't think about. It's taken for granted. There's also some supposition, oh, it'll never happen to me. Those things are rare. It's always somebody else. But I think if you do your planning right and you play your cards, well, not even play your cards, just do your planning right, it won't happen to you and you will be safe. So I think there's a lot of great information, and I'm looking forward to reading all the show notes myself.
Good deal. Dean Wilson, thank you so much for being with us. I'm sorry we're out of time, but you've just been terrific, and I appreciate you taking the time, and I appreciate all the work in your career that you put, that you assemble so you can boil this down to an hour presentation and get people thinking about this in the right ways. Thank you.
Well, it's my pleasure, Chris, and Kirk, to be with you. Thank you.
All right. Chris, I guess we're about done. You want to take us out of here, please, Chris?
Sure will. Well, again, everybody, this has been the SBE WEBxtra, the SBE chapter of the web. We present this monthly, and we hope you'll join us each time. We'll post the replay on our YouTube channel probably by tomorrow. The SBE WEBxtra is sponsored by Catrine, whom we thank for their support. Catrine, unique experience, individual solutions, reliable performance. If you hold SBE certification, viewing the SBE WEBxtra qualifies you for 1/2 point in Category G, that's under attendance, just like attending a local chapter meeting. And that does it for this installment of the SBE WEBxtra from the Society of Broadcast Engineers, the Association for Broadcast and Multimedia Technology Professionals. Thanks again to our guest, Dean Wilson, and on behalf of Kirk Harnack, we'll see you next month.